Good morning. In this lecture series, we are going to focus on Uart, Universal Asynchronous Receiver Transmitter. You just look at this picture representation, how the two PCs, personal computers, communicate. So these two personal computers are communicate with the help of the serial cable and then modem. Before diving to that actual scenario of UART, for the communication, better communication, we have a two different end. One is the transmitter end, another one is the receiver end. If one device is ready to give information to other device, then other side second device is ready to accept. Then only we can establish the proper and good way of communication. If the second device is not responding, default the information is going to last. Here the UART has a transmission engine and also a reception engine. These two different engines are operate simultaneously. For UART communication, software is play a major role. The software controls the UART operation by accessing the several registers in the CPU with the help of the instructions. So we have written some code to configure the control of the communication part. Proper understanding of the UART, we must know little bit history of the terminologies we are using in the UART. This is the pictorial representation of how the data from the one devices is coming out. We have a set of code, software code. This software code tells to start the communication. All right. So at the time, so what happened? End of that transmission, we have a transmitter hold register and then transmitter internal shift register. These two play a major role. Before coming out to the devices, the data are available in these two registers. Software outputs a byte of data, so all the informations, all the data are transmitted or coming out from the devices in the form of 8-bit. The transmitter holds the transmitter holding register have the 8-bit of data. This 8-bit of data is immediately copied to the internal shift register. These shift registers is popping out of the 1 bit at a clock pulse of trigger. Right, so 8-bit of data is popped up for each and every clock pulse is triggered from the internal shift register. Before and after starting of the data packet, 8-bit of data, there is a start bit and stop bit, which is giving the information to the second device. The data is started, communication is started. 1 byte of data is communication is started and then end. Just reverse of the data transmission in the second device having the data reception. Before moving to the data into that CPU or software control unit, we have receiver buffer register. By that, above the internal shift register, receiver internal shift register. So each clock pulse trigger voltage is sample a bit shift at a regular interval. The 8-bit of data is transferred to the receiver internal shift register. This receiver internal shift register immediately copied to the receiver buffer register. So after receiving the 8 bit of data, 1 byte of data, this data is considered for the further operation by the software. Software can input the received byte from the receiver buffer register. So another two terminologies most important. Why? Because from that history, data communication equipment, data terminal equipment is most important. Why? Because we have a you originally developed the UART for communicating the PC to telephone network. As we know that telephones are voice communication analog signal, where the computer is digital signal. For this we need some special equipment is required for this conversion, that is called the modem, so, or modulator or demodulator. So why by that modem only these conversions, analog to digital and digital to analog, has to be done. The final lecture of this video is Uart frame format. This is the data which we were seen in the previous slides. As you know that if you have one data is ready to communicate, there is a one start bit, another one is the 1 or 2 stop bit. So in between we were stuck with the data frame, maybe 8 bit or 8 bit is given in the previous slides, but in the data format they will represent 5 to 8 bit of data we can stuff between the start and stop bit. Another one more bit is inserted between the this in this format, that is the parity bit, which gives the even parity and then odd parity. If we look into the start bit, the UART data transmission line is normally held at the high level. So UART is the high voltage, that is 1, when it is not transmitting the data. So generally if you are start communication, its start bit is the high level because it's not start bit transmitted. To start the transfer of the data, the transmitting UART pulls the transmission line from high to low for a one clock cycle. Similarly, when the receiving UART detects the high to low voltage transition, it begins reading the bit of the data frame at the frequency of the baud rate. So as you know that the data frame contains the actual data being transferred. It can be a 5 bit or up to the 9 bit of long. So if the parity is used, if no parity bit is used, then the data frame be 9. So 5 to 8 bit of data frame if no parity is used. If the data parity is used, it's a 9 bit. In the most cases, the data is sent with the least significant. So which bit is coming out from the transmitter? LSB. So least data is sent with the least significant bit first. Then parity, as you know that parity usually we are observing for the data loss, even parity or odd parity. So parity describes the even or odd number. The parity bit is a way for the receiving the UART to tell if any data has changed during the transmission. How the data bits can be changed? By maybe the electromagnetic radiation, mismatch the baud rate, or long distance data transfer. So if you have a practical exposure of the communication, so when you are going to communicate your device with your PC, so if you are not properly set the baud rate of 9600, then you have some garbage value in the display, which means the baud rate for your PC and the device is not synchronized. At the time you will receive the some unwanted informations. So after the received UART reads the data frame, it counts the number of bits with the value of 1 and check if the total is an even number or odd number. If the parity bit is 0, the 1 or logic high bit is the data frame should be total and even number. If the parity bit is a 1, the 1 bit of a or logic high in the data frame should be total of odd number. When the parity bit matches the data, the UART knows that the transmission was free from error. When the parity bit matches the data, the UART knows the transmission was no error. So proper data we were received. Sorry. If the parity bit is 0 and the total is odd, or the parity bit is 1, the total is even, then the UART understand the bit frame have changed in between the transmission. So that is the impact of your parity bit. We can check the error whether the data properly or changed in between the transmitter and receiver by some other external factors. So start bit to sign the start bit have a 1 or 2 bits to signal the end of the data packet. So we have a packed the data, we have a data or packed at the end of the data packet, the sending your devices the data transmission line from a low voltage to high voltage for 1 or 2 bit duration. So 1 or 2 bit duration we are having the voltage from low to high. So that indicates the UART, that is data is completed. 1 byte of data is received. It's understood from the receiver end. This is about the UART frame format. So by the conclusion, we have a universal asynchronous receiver transmitter. We focused on the different terminologies and then data format, how the data are coming out from the transmission and how the data feed into the receiver end. And then finally, so if a communication of 1 byte of data, so what are all the different segments present in the data? So every data there is a start bit and then stop bit. From the ideal condition, UART has the high level of signal. Once if it is coming to the low level for 1 clock pulse, then the UART is ready to transmit. So after that data is transferred 5 bit to 8 bit if there is no parity bit, 5 to 9 data bits if the parity is present. From the parity bit, odd and even parity we can represent. From that odd and even parity we can observe the data is transmitted data is error free or with some error. And then last finally stop bit. So 1 to 2 bits we are observing low to high whether the communication is terminated, that is 8 bit of data is received or not. So that's all about the UART. So thank you.